Hey friends, how are you doing today? Let me ask you a quick question. Have you ever looked at two math expressions that look almost the same, but somehow give totally different answers? If yes, you're not alone. In basic math, these little differences can trick anyone. So today, we'll go through some of the most common confusing expressions in algebra, side by side, and I'll show you exactly how to tell them apart. By the end, you'll feel way more confident and avoid mistakes that so many people make. Ready? Let's get started. 1. Negative numbers and exponents. First up, the classic trap. Negative 3 squared versus negative 3 squared. Now here's the trick. The order of operations matters. In negative 3 squared, the square applies to 3 only, and then the negative is applied after. Therefore, we get negative 9. But in negative 3 squared, the parentheses make the negative part of the base. So squaring negative 3 gives us positive 9. See how those tiny brackets completely flip the answer? 2. Squaring a binomial. Next we will see this. A plus b whole squared. Many people think it's just a squared plus b squared, but that's wrong. Whenever you square a binomial, you get 3 terms. That is, a squared plus 2ab plus b squared. That middle 2ab comes from multiplying a by b twice. So remember, a plus b whole squared is called a perfect square trinomial. Don't forget about the middle term. It's crucial. 3. Squaring a product. Now let's check this expression. ab all squared. This one's much simpler. When we square a product, we just square each factor. Therefore, in this case, it would be a squared times b squared. The easy rule is, if a product is inside parentheses, apply the exponent to each part. 4. Multiplication versus addition. Here's another easy to mix up one. X dot x and x plus x. X dot x means x times x, so the answer is x squared. But x plus x means addition, therefore the answer is 2x. They look similar, but multiplication and addition behave very differently. 5. Square roots with products versus sums. Now let's clear up a common mistake with square roots. We've got two expressions. Square root of a times b and square root of a plus b. Now the first one is nice. We can break it down as square root of a multiplied by square root of b. That's a legit rule, called the product property of radicals. But the second one? Square root of a plus b? We cannot split that into square root of a plus square root of b. That shortcut just doesn't work. So remember this simple idea. Square roots play nicely with multiplication, but never with addition. 6. Zero and exponent rules. Let's look at 1 to the power of 0 and 0 to the power of 1. Here's the key rule. Any non-zero number raised to 0 is always 1. Therefore, 1 to the power of 0 equals 1, and 0 to the power of 1, that just equals 0. But be careful. 0 to the power of 0 is undefined, so stay away from that one. 7. Multiplying powers and adding exponents. Next one, x to the power m dot x to the power n versus x to the power m plus x to the power n. If we have the same base, multiplying powers means we add the exponents. Therefore, for the first expression, we get x to the power of m plus n. But if we are adding powers, like x to the power m plus x to the power n, that does not equal x to the power of m plus n. We can't just combine exponents in addition. Addition doesn't follow the same rule. 8. Square roots and absolute value. This one confuses a lot of people. Let's compare square root of open bracket, negative 2, squared close bracket, and open bracket, square root of negative 2, close bracket, squared. The first expression isn't just 2. It's the absolute value of negative 2. written as the absolute value of negative 2 equals 2. Why? Because squaring a negative number makes it positive. Negative 2 squared gives 4. Take the square root of 4, and we get positive 2, not negative 2. On the other hand, that doesn't even exist in real numbers, because we can't take the square root of a negative. Only in complex math does square root of negative 2 make sense, and if you square it, you get back negative 2. 9. Fraction simplification. Let's clear up fractions. A plus b over a versus a times b over a. For the first one, we can split it into a over a plus b over a. Now, a over a is just 1, so this simplifies to 1 plus b over a. But for the second one, since the numerator is a product, we can cancel the a's. That leaves us with just b. So remember, the key difference is whether the numerator is a sum or a product. Awesome! You've just learned 9 powerful examples of math expressions that look similar, but actually mean totally different things. If you had fun learning, smash that like button, share this with a friend, and make sure to subscribe so you never miss out on more math tricks. Thanks for watching, and let's keep learning together in the next one.